Hi guys, I'm Nancy and I'm going to show you the chain rule for finding derivatives. I know you might not be super pumped about learning the chain rule, but here's why you should care. The chain rule saves you time, and time is the one thing you can never get back. So let's take a look at the chain rule. So what is the chain rule, and how do you even know when you need the chain rule? Those are excellent questions. What is the chain rule? It is the way to find the derivative when you have a more complicated equation that is a function inside a larger outer function. And it will make your life easier, I promise. So let's look at this one. You need the chain rule when you have a smaller x expression or function inside a larger function, outer function, and the inside is something other than just x. So this one is ripe for using the chain rule. It is begging you to use the chain rule. So let me show you how you do it. So the name chain rule is a little cryptic as to what to do, but thankfully it has another name, the outside-inside rule, outside-inside rule, that tells you exactly what to do. To find the derivative dy dx or y prime, you take the derivative of just the outside function first, the outer function, and leave the inside part as is, alone, untouched. And then after that, you multiply by the derivative of just the inside function. So let's try it with this one. So dy dx for this function, or y prime, if you see that instead, will be equal to the derivative of just the outer function first. In this example, the outer function is this power of 7. So you want to focus on just that outer function form, the power of 7, and take the derivative of that. You can even just ignore the inside part for now. To take the derivative of a power, you use the power rule, which hopefully you've seen before, but it means that you bring down the power out front as a coefficient. So we bring down the 7 out front. And you also knock down the power by 1. You reduce the power by 1, so that power becomes 6 instead of 7. And for the chain rule, for now you leave the inside part alone, the way it is. So this 3x plus 1, just for now, will stay the same. Now, you are not done with the chain rule because you have something more than just x inside. If this were x here, you would be done. But because there's an inner part, you have to multiply by the derivative of the inside function as well. It also has a derivative component. So you focus on just that inside expression, 3x plus 1, and you take the derivative of just 3x plus 1, ignoring the outer power. Hopefully you've seen derivatives like this before. The derivative will just be 3, because for this term, 3x, it's the constant multiple rule. The derivative of that would just be 3, the number out in front of the x. And then for the plus 1 term, the derivative is just 0. That part goes away because the derivative of any constant is always 0. So that whole derivative is just 3. And you're pretty much done with the chain rule. You can clean this up a little bit and simplify. And that is your derivative. Dy dx equals 21 times 3x plus 1 all to the 6th power. I combine the 7 times 3 out front. If you were confused about the power rule, you can look that up. That's a separate topic, another video. Basically, you bring that power down out front as a coefficient and then reduce the power by 1. So that's how you do the chain rule in general. Now the question is, how do you know when you need it? So for that, let's play a little game of chain rule or no chain rule. So how do you know when you need the chain rule? For this one we just did, definitely needed the chain rule. What if instead you'd been given a function like this, 3x plus 1? Would you need the chain rule? No, because that 3x plus 1 is not inside some outer function. So you don't need the chain rule because it is not a composite function or composition of functions, so no. What about x to the 7th power? You do not need the chain rule because it's just x to the 7th power. If you had something in parentheses more than x raised to the 7th power, you would. But as it stands, it would just be overkill. Do not need the chain rule. 3x plus 1 to the 7th power should look very familiar. We used the chain rule on that because it's an inside function in a larger outer function. It's a composite function. Definitely. The inside derivative ended up being 3, and we didn't want to miss that part by not using the chain rule. What about x plus 1 raised to the 7th power? This one's a little tricky because technically you should use the chain rule. It's a composite function, but when you do it, you'll see that that inside derivative is just 1, and multiplying by 1 won't actually make a difference, so it won't matter. There are cases like this, but the thing is, it can't hurt to use the chain rule. It's like, it's better safe than sorry, so it's a good policy to use the chain rule even then. I'm going to say yes. Yes. And then what about x squared plus 1 all raised to the 7th power? Definitely use the chain rule. You'll get some inside derivative that is 2x, so it's important not to miss that. So really quickly, some of you might be wondering in this one that we had just did, why couldn't you just multiply this all out, distribute it, FOIL it, and then take the derivative normally like you'd been doing before with the power rule? You can do that. Feel free to do that. Do it at your own peril, at your own risk, because it sounds like it will take a lot of time, be very tedious, and be kind of painful. That is why the chain rule is your friend, because it's saving you that time and that pain, and it makes taking the derivative of something like this much, much faster. So let's take a look at another type. So here's another one, more complicated example. What if you need to find the derivative of something like this? It's the same steps as before. Use the chain rule. So we want to find the derivative of h of x or h prime of x. Sometimes that's called dh dx if you see that. But the derivative of h of x, h prime of x equals, let's use the chain rule again. First take the derivative of the outside function, this outer part, the power of 9 only, so you'll use the power rule and bring down the power to the front. Leave the inside the same, just leave it the way it is for now. And reduce the power by 1, so instead of 9 we have a power of 8. Remember, you are not done. Also need to multiply by the derivative of what is inside of just that. You'll use the power rule for this. The derivative of x squared plus 5x minus 6 will be 2x from this part plus a 5 from this term and nothing from the constant that contributes nothing to the inside derivative. So the derivative of this will be 2x plus 5. You are actually done. You don't really need to expand that or anything. That is the answer for h prime of x, the derivative. Now let's play a really fast lightning round of chain rule or no chain rule. So really quickly, would you need the chain rule for something like this? No, it's not a composite function. X to the 9th? No, not complicated enough. Don't need the chain rule. X minus 6 raised to the 9th power? Technically, yes, it may give you an inside derivative of 1 that won't end up mattering, but I'm going to say yes, it's a good policy. This one, definitely, it's the one we just did, begging you to use the chain rule, that composite function. So let me show you one last kind of chain rule problem, I promise. Okay, here's another example. It's trig, don't get too excited. By now you're probably getting the hang of this, but just humor me. Let's do this one to find dy dx. It's the same steps as before. You use the chain rule, take the derivative of the outside function. The outside function here is sine. It's the sine of something. And the derivative of sine is cosine. So we write cosine. Keep the inside part the same for now. And then we need the inside derivative and just focus on the x expression that's inside the sine function. The derivative of x squared minus 3x is just 2x minus 3. And that's it. That's your answer. dy dx is equal to cosine of x squared minus 3x times 2x minus 3. Okay, what if instead you had just sine of x? Would you need the chain rule? No, there's no complicated inside function. Sine of 3x? Yes, because this 3x is the inside function within the larger sine function. And what about sine of x squared? Yes, again, the x squared is inside the sine function, so you'll need the chain rule. So you might be wondering, why do we even need to do the inside part? Why couldn't we just do the cosine of x squared minus 3x and be done with it and not have to do that inside part? That would be too easy. This might be a good time for me to show you the official formula for the chain rule. Okay, here are the official chain rule formulas. I have two versions here to show you. It's kind of what you already know, what you've been doing. This is a composite function, one function inside a larger outer function, and if you have to take the derivative of that, you will need an outside derivative times an inside derivative. That over there is Leibniz notation, if you have to use that. Just so you know, this first part, dy du, corresponds to the outside derivative, and the second part, du dx, corresponds to the inside derivative, if you have to use that, if you're stuck with Leibniz notation. Anyway, this inside derivative is important. You can't leave it out, or you won't have the right value for the overall derivative, overall rate. If you want the derivative with respect to x, you have to keep taking the derivative until you truly have it with respect to x. Otherwise, you're missing that part of the rate. Why is it called the chain rule? Because you could have many functions nested inside each other, more than just two. This is just g inside f, but it could keep going. G inside f, inside e, inside d, etc. And if you had something like that, your derivative would just be this chain of smaller derivatives multiplied together. Smaller derivatives linked together, and you would need all of them to get the right value for the overall rate, the overall derivative. Which brings me to my last thought. So I lied. One more example. You may need to use the chain rule more than once. Repeat the chain rule, double chain rule, or extreme chain rule. This is where it gets pretty trippy. Let me show you. If you need to take the derivative of this, so y prime, start just like you've started the others. Take the derivative of the outside function, the square, the power of 2. That power reduces, so you have a 1 power, which you don't need to write. Take the derivative of the inside function, the 1 plus cosine 2x. Derivative of 1 is nothing, it's 0, but derivative cosine is negative sine, so we have negative sine of 2x. But you're actually not done, because when you took the derivative of the inside, you got something that has its own inner function. As another function nested inside 2x. Because you got something that is not just sine of x or even negative sine of x, you have a 2x inside, you have to keep going and use the chain rule again. and find the derivative of that inside 2x. Derivative of 2x is just 2, so you're multiplying by 2. So that's the answer. You had to use the chain rule twice. The chain rule can come up in many forms. You may have to use the chain rule inside a quotient rule, inside the product rule. You just have to watch out for it. You could even use the chain rule 3 times, conceivably, I guess. Let me show you a few more forms where you'll need the chain rule. Here's some other kinds to watch out for where you'll need the chain rule. E to the 3x, you have a 3x inside an exponential outer larger function, you'll need the chain rule. Logs, this 5x is inside the natural log ln, so you'll need the chain rule. X squared plus 1 is underneath the square root. The square root is your outside outer function, so you'll need the chain rule in that case. You could also see this in that form of a fraction power. So the outside function is the power to the 1/2 and the inside function is x squared plus 1. Just want to watch out for the chain rule. It's really easy to forget it sometimes when you need it. So just watch out for things that are smaller x expressions within larger function forms. So I hope this video helped you understand how to use the chain rule. I know calculus is everyone's favorite. It's okay, you don't have to like math, but you can like my video. So if you did, please click like or subscribe.